if we graph, you can just kind of sketch this out on your map, on your paper. If you graphed y equals x plus 1, okay, if you graph that out, when you graph, first thing you do is go up using the y-intercept, okay? So you would plot your y-intercept, okay? After that, you would look at your slope, okay? The slope is what? 1. So you would go up 1 and over 1. And you would keep on going. And then you'd graph it out. And then you'd connect the dots, okay? Also, let's say if we had a negative x, y is equal to negative x minus 2, okay? If you graph that out, same thing. Y-intercept first. Go ahead and dot your y-intercept. And then your slope is what? So you would go where?
Down 1.
Over 1. Down 1, over 1. Down 1, over 1.
Well, no, it would be x over 1, and we don't know what x is.
That's an imaginary 1 when you're talking about slope. Everybody good?
So why are we imagining it? No.
You
X
just-
should be imagining you.
Okay. I don't think so. Anyways.
Black one.
Why is everything black or white to you?
I'm black and white.
Okay, that's fine. We don't need to know. It's okay. It doesn't matter.
You guys have property black one.
Okay, so now, 2 more things. If you had, guys, pay attention. If you had a y is equal to 4, and you went to graph that out, first thing you do is always address your y-intercept. My y-intercept is what? 4. Okay?
And then you go straight.
And so when you go to graph it, no, stop. Otherwise you get out of my class. Seriously. Okay? So when you go to graph it,
It's straight.
it would be straight across, not vertically, horizontally. Okay? This should be a quick review. Now, let's say if we had an x is equal to a negative 2. If x is equal to negative 2, you go negative 2 on the x-axis, plot your point. Would you go vertically or horizontally?
Horizontal.
Vertical.
That's what I meant. Oh.
Okay?
I confused him
Noah.
on vertically.
No. Hush. Just don't even talk to anybody. Don't talk to anybody.
So x is like the longitude and y is latitude.
Yeah.
Sort of.
Okay, now, step further. Okay. Whenever you do let's do y is less than 3. Okay? So, when you read this, y is less than 3. Okay? So, the values that would 4 work? Is 4 less than 3? No. So if we're talking about just the y-axis, okay, literally it's all we're just focus on the y-axis, okay. Now, only look at the y-axis. If y is less than 3, so all the values that are less than 3 would work. So let's say if we plotted at our point of 3, okay, all of these values less than 3 would work. I want to show that all the values less than 3 would work.
I understand that shaded part, but
Okay.
what is that?
You don't remember?
If we had this inequality right here, y is less than x plus 1, okay? First thing that you should do, guys, pay attention. Otherwise, I'm not going to repeat. My voice is going out. I'm not going to repeat this like 20 times.
Does this associate with the
Yes.
dotted line and all this
Yes.
stuff?
So, if you had this inequality, y is less than x plus 1, the first thing that you should do whenever you're graphing it is do what?
Put your y-intercept on there.
Put your y-intercept. Think of this as x plus 1. Don't worry about the inequality so much when it comes to graphing it out. Now, when it comes to shading it, you need to worry about that. But when it comes to graphing it, graphing the actual line, you just need to look at the equation. If it's x plus 1, your y-intercept is going to be 1. So you would make that point. Now, what is my slope? Connor, please stop doing that. My slope is 1.
Yeah.
So I'm going to go up 1 over 1. Up 1 over 1. Up 1 over 1. Okay?
Okay.
Now,
And then you're gonna shade everything below it.
next thing. You need to make a little box at the top of your paper, on the side of it, wherever. Chase, don't do that. You need to write this out. If you have a less than or greater than sign, that equals a dotted line. That means you're making a dotted line. If you have your equals to, like your less than or equal to or greater than or equal to, you have a solid line. Make sure you have that down. When you're looking at our equation that we're doing, our inequality, okay, this means a dotted line. So you would make it a dotted line. Now this is just a rough kind of graph of it, so this is not perfect. Okay, it'd be a dotted line. So you graph your equation. You decide if it's going to be a solid or dotted line. The last step to this is determine where to shade it. Now, if this says y is less than your equation, you need to look at the y-axis, and you need to think y is less than. Which values are less than on the y-axis? Which values are less than our equation? Down or up? It would be down. Good job. Yes. Because, heck, this would be a negative. This is like a negative 1. This is like a positive, I don't know, 3. Okay? Negative 1 is less than 3. You want to get all your values less than your equation. So you would shade it down.
Wait, how, I'm still not getting how you get
So above that line,
Okay? So if we had this equation, and we graph this out, guys, make sure you understand this because the next part's going to be a whole lot complicated, more complicated, so pay attention. Okay, so if I'm graphing this, the first thing you need to do, don't worry about the inequality in the sign. Don't worry about that. Graph the equation first. Graph the line first. So my y-axis is, my y-intercept is 2. So I make my little point at 2. My slope is 1, so I would be going up 1 over 1, up 1 over 1, up 1 over 1. No.
But sometimes it'd be like 2x and then your slope would be 2.
Yeah, it just depends. Now, once you have graphed your line out, Connor, turn around please. Okay, once you have graphed your line out, now decide if it is a dotted line or a solid line. Dotted, perfect.
You know if it's dotted because of the sign?
Yes.
This don't look like that.
Okay, that's fine. You get the point. Okay, now we look at the sign. If y is greater than, it's going to be on the top because we're looking at the values that are greater than.
So every single time it's greater, every single time you're going to go above the line.
Not every time.
but you're shading
This is easy.
X minus.
Okay, this value is y is greater than 4. Now, remember, don't worry about the inequality. Don't worry about that yet. Worry about graphing your line. Now, this is essentially y is equal to 4. So there's no slope. So when I go to graph this, you need to go on the y-intercept and go up to 4 and dot your point.
Then you put your line across and you shade up.
Now your line is horizontal.
Yeah.
Now, is this a dotted or solid line?
Dotted.
Good. Okay?
And would it be above?
Now, this is saying y is greater than. So then you'd be going up. You're going to the greater values. So you'd shade it up. Okay? Sorry. Should have made that one. Let's do one more. Now, let's say if we had this. Now remember, look at your equation first. That's what you need to be graphing out. This is essentially x is equal to 6. Okay? There's no slope. So, you need to work with the x-axis and graph out 6. 1, 2, 3, 4, 5, 6. Somewhere over here. Now the next step to this, decide if it's dotted or solid line.
Solid.
This would be a solid line.
Solid.
Make sure when you graph this vertically. Okay?
That's it.
Now,
You don't shade it, do you?
if x is less than, all the values that are less than,
You shade it on the opposite.
you need to shade values that are less than 6.
On the left, yeah.
Okay? All those values would work. Okay, so let's look at this first equation. The first one, the top one. Okay, let's look at this first one. Okay. All they did was, if you look below it, they graphed this equation out. Okay, they have a y equals 2x plus 1. They made their line dotted. Okay. And the last step to this is the sign is saying y is less than. So they looked at the y-axis and they shaded all the values that were less than. Now you can't really see that, but all this is yellow. That's what they did. If we're just looking at this first equation, they shaded all this yellow. That's essentially what they did. Okay? Okay. Now, let's look at the second equation.
What's a solid line?
First of all, they graphed it out. Okay, they graphed out their line. It's a solid line because it is greater than or equal to. Okay? And the last part to this is they shaded y is greater than. So, if we're just looking at this line, they shaded greater than. So they shaded more. That's what they did.
They made it green.
Do you understand that? Those two lines. Those two shadings.
No, hold on. I did.
If you combine if you combine yellow and blue, you get the color green. Now what that means in the context of the actual equations or the inequalities is these values that are green overlap. Okay, the yellow and the blue overlap, which makes that green. Which means that all those points in that fit this system of inequality. All the x and y coordinates in that fit this inequality. Okay? Connor, when we're solving for inequality, if we're trying to get this in slope-intercept form, we want to solve for y. Okay? We want this in y equals mx plus b. Now, don't worry about the inequality sign. Okay? Don't worry about that. So from here, we need to solve for y. Okay? So we need a minus 2x from both sides. So y is less than negative 2x plus 4. So that works. Now remember,
So your y-intercept will be +4 and your slope will be negative.
yes. Now, okay, if we had this equation, or this inequality, okay, and I am solving for y, I'm doing the same thing. I minus 3x from both sides.
Oh, we were on the new one.
3x. Oh.
You have to remember that whenever you divide or multiply by a negative number, you flip the sign. So, to get this negative by itself, I have to divide both sides by -1.
This makes so much sense, actually.
So that flips that sign
It's really only does it change all the signs from both sides.
and flips the sign.
I see.
Okay?